Okay, 1.4 in your textbook, page 41. We're talking about rational numbers. So, a rational number, it's a number that can be expressed as the quotient of two integers, where the divisor is not 0. It sounds complicated, but really it's not. Another way of kind of thinking of rational numbers is just fractions. Okay, so when I say fractions, you think of things like this. Okay, 3 over 5, 1 over 5. 3 over 1 can also even be considered a rational number. Okay, so whole numbers like 3, 4, 5, 15, they can also be considered rational numbers because we know any whole number can be easily converted to a fraction by just putting it over the value of 1. Okay, so all of these are rational numbers. The only exception is you can't have the denominator being a 0. Okay, if we have any number like 1 over 0 or 10 over 0, 5 over 0, all of these numbers here, these are undefined. Okay, we don't know what those numbers are. If you try that on your calculator, divide any number by 0, you're going to get error. Try that now. What do you get?
Divide by 0.
Undefined. Okay, good. All right, so if we have a number divided by another number, or even if we have a decimal number like 15.5, we know 15.5 is the same thing as 15 and a half. So this is also considered a rational number. Okay, or if we have 15.63, this is considered a rational number. Can anybody tell me the fraction? Can show me that in a irregular fraction? Or a mixed number. Josh?
Oh, wait, 15.63 over 1.
No, you can't have a decimal in the numerator. You can't do that. Michael?
1563 over 100.
Excellent, good. Yeah, you can express that like that, right? And if you wanted to convert it to an irregular fraction, you could do 15 times 100, so that would be 1500, and 16.3. Okay, so any decimal number then we can raise, or we can write it as a rational number. Even if you had a number like 3.1456168, you can always write that as a fraction as well. Right? You're going to write, that's the same as 3145168 over yeah.
So basically any number that doesn't have a denominator of 0 is a rational number?
Yes. Yeah. Josh.
Could you do a number like, I don't know, 0.349?
Right? Okay? So almost really when we think about it, any number can be expressed as a rational number. But when we think of rational number, I want you to think of like a fraction. That's typically what we're referring to. Okay? All right. Moving on. Okay, so the first question on page 41, it says determine a possible temperature value that's between -18 and -19, but is closer to -19. So they teach you here to use a number line. I don't like number lines that much, but we're going to show you how to use them anyways. Okay, so if we look at this number line here, we can see zeros in the middle. As we move to the right, it's positive. As we move to the left, it's negative. Remember, if we're further to the right, we're larger. Okay? Numbers get larger going this way, they get smaller going this way. So if you look at a number line, it's important to recognize that negative 10 is larger than negative 20. Do you guys understand that concept?
Yeah.
So even though 20 appears, or you think of 20 being bigger than 10, when we're on the negative scale, negative 20 is actually smaller than negative 10, okay, because it's further to the left. Okay, so that's kind of the importance of the number line. It kind of allows you to see that moving to the right gets larger, moving to the left gets smaller. So I'm going to blow up this area here. Okay, when I mean blow it up, I'm going to just redraw it, but at a larger scale. Okay, so this is okay, so please draw that. Now in each number, between each number, I'm going to actually break it down further into quarters. Okay, so the question tells us, determine a possible temperature value that's between negative 18 and negative 19, but closer to negative 19. So here's negative 18, here's negative 19. It wants me to give a temperature in between there, but closer to negative 19. So I really only have, on my scale, I really only have one option, right? Based on this scale. If I pick this point, what's that value? Mark, what's this value?
18 and 2 and 3 over 4.
No, that would be the right one, but I picked this one. So here's 18, here's 19. What's that value? It's in the middle, between 18 and 19.
2 over 4?
Okay, yeah, 2 over 4, 1/2, right?
Yeah.
So this would be, this point here would be negative 18, 2 over 4. Okay, or 1/2. Negative 18 and a half. But it says it wants me to be closer to negative 19. So in this case, I'm not closer, I'm in the middle between 18 and 19. So I actually want to pick this point here. That's this point. Noah?
3 over 4?
Yeah, what 3 over 4?
Negative 18.
Good, negative 18 and 3/4. Okay? So everyone understand how to read this number line? As we move in this direction, we're going to a higher negative number, lower numbers. In this direction, we go up. So if this is 17, 17 1/4, 17 1/2, 17 3/4, sorry, negative 17, negative 16 3/4, negative 16 1/2, negative 16 1/4, negative 16. Okay, so you're almost counting kind of backwards. As you move in the right, you're going down on the number scale, the negative number scale. Okay, damn.
Can't any number lower than 18.5 be right? Like between negative 19 and negative 18?
Yeah, but on this scale, I only really had that choice, right? Based on this particular scale. You're right, though. I could have chosen negative 18 and 9/10, right? But then I don't have that notch here. Okay, it would have been much closer to there, right? Okay? Any other questions about that? All right, so we've chosen that value there. So I hope you guys are okay working in with negative numbers. Because in the book, what they do is they replicate the negative number on the positive scale, then find out the value, and then go back to the negative scale, all because they're not comfortable moving in a negative direction. I don't want to bother to do that. Okay, so please let me know if this presents a problem for you guys, moving negatively and realizing that these numbers are lower. Okay, you guys are fine with that? Okay, so let's move on. The next example, this is on page 43, example 2. Actually, this is fairly important and people can get confused here. Okay, so in this example, the question reads, which of the following represent the same rational number? So we know all of these are rational numbers. Why? Because they're fractions, right? They're one number with a quotient between another number. It says which one of these represent the same number? So it can get confusing as you guys get into more advanced math. All these negative signs are going to float around. You really got to keep track of them. Okay? A lot of the times in textbooks you'll see this a lot. Okay? Negative 2/3. And the negative sign will sit in the middle, right between the 2 and the 3. This can be confusing because sometimes if you need to do a multiplication or a further process with this number, you really want to decide whether that negative sign is with the numerator or if it's with the denominator. Because it's definitely not with both. Okay, you guys have to be aware of that. When we have this value, it is not the same as this. Okay? So what they do in the textbook is they take each value and they divide it. They just put it in their calculator. And what they find out is they say, well, negative 2 over 3 is equal to negative 0.6. They find 2 over negative 3 is equal to negative 0.6. And they also find out that this. Okay, so they realize that, well, all three of these fractions are the same because they give me the same decimal value. Yeah.
If it's in the middle, where does the negative sign belong to?
On your calculator, you would just press negative, and then you'd have to use that fraction button like this.
So it belongs to the numerator?
It's up to you. You can choose whether you want it on the numerator or the denominator. I always choose to put it on the numerator, just to keep things simple. Yeah, so I would leave it with the numerator. But it's important to recognize that this, and this are all the same. They're all the exact same. Okay, it's just a different type of nomenclature, okay, or a different style of writing the same value. What is very important to realize, but this, however, is not the same. You go and contribute that negative sign in the middle to both the numerator and the denominator. What happens then is you have a negative value divided by a negative value. This becomes positive 0.6. Okay, so this guy is not the same. Likewise with 3 over 2, this value would be the same as, would be equal to negative 3 over 2, would be also equal to negative 3 on the numerator divided by 2. But it's not equal to this value. They are not the same. Not equal. Because negative 3 over negative 2 is positive 3 over 2. Alright? So in this case, this is equal to this. Okay? And that's because these negative signs, they cancel out. Any questions? Alright, that's important. Please remember that. Finally, the last example. Try and fit this one in. So it says determine which number is greater, negative 3/10 or negative 1 2/5. So first of all, before we start comparing them, let's put them on the same denominator. So this is going to be negative 1 over 4/10. Right? So I'm just multiplying the denominator by 2 here. So we have the same denominator of 10. So one way you can do this is you can actually use a number line and draw it out. So this would be 0, if this is negative 1, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each one of these represents 1/10. So this one, negative 1 3/10. Sorry, let's put 0 up here. I'm going to put 1 here, negative 1 here, and negative 2 here. Okay, so negative 1 3/10 would be negative 1 and 1, 2, 3. So this point here, that's negative 1 3/10. Negative 1 4/10 would be this point, 1, 2, 3, 4. That would be this point here. Okay, and then it says which one is greater? So who can tell me? Philippe? Yeah, 1 3/10 is greater. Why? Because it's further to the right. Okay, it's a bigger number. Even though it's smaller than 3/4, because we're negative, it's greater. The smaller negative number you are, the greater you are. Okay? The larger negative number, the smaller you are. So you can either use a number line or you can just remember that fact. Okay? As you get larger in the negative numbers, you're getting smaller. Right? Negative 100 is much lower than negative 1. Make sense? Any questions about that? Okay, that's really kind of the focus of today, is just not getting confused with these negative signs. Okay? And finally, I want you to copy the table down on page 44. Okay, I'm not going to rewrite it here, but you can find it on page 44. It's at the bottom. There's a table there, and it explains the difference between natural, whole numbers, integers, and rational numbers. I can't do a better job of explaining it. Just you can read the definitions there. The only difference is with this natural numbers, you don't include the 0. Whole numbers, we know what a whole number is, but it also includes a 0. So whole numbers include a 0. And integers include the negative numbers as well as the 0. So natural and whole numbers don't include negative numbers. Integers do. They also include the 0. And rational numbers basically include all of those things, with the exception that they're written over another number. Okay, so they're written in the form of a fraction or a quotient. Okay, but you can see there they also give decimal values. Okay? And that's the end of lesson 1.4.